Good evening, everyone. We are so glad that you could join us tonight. My name is Charlene Margot. I'm co-founder of nonprofit The Parent Venture that brings you this program, the Parent Education Series, now starting its 19th year. We are delighted to have with us tonight Dr. Christa Jackson, who's going to be talking with you about fostering mathematical brilliance in all students. That was the title of an article that she wrote that I ran across, I think, this summer. Is that right, Christa?
Yes.
I just thought such a wonderful title and a wonderful topic. I wanted to bring it to this program. Please join me, everyone, in a really warm welcome for Dr. Christa Jackson. Take it away, Christa.
Thank you so much, Charlene. And I'm very, very excited to join you this evening. And I would like to go ahead and begin by sharing my screen. And as Charlene had mentioned, we're really going to dive into fostering mathematical brilliance in all of our students, our children, as well as our nieces, our nephews, and even the mathematical brilliance in ourselves, even though we may not have thought or considered ourselves that mathematically brilliant, but I would like us to reconsider that at this time. So to begin, I would like us to just take a moment and think back to a time when you were in school. Consider your time in elementary, middle school, and for some of us, junior high school, just because of our time span, high school as well as college. Which mathematicians or names of mathematicians did you discuss during mathematics class? I'll give you a moment to reflect on that. Now, who was the first mathematician that came to your mind? I would like you to take a moment to think about that, as well as take some time to post that first mathematician that came to your mind on this chat using the QR code or that link. So just take a moment just to enter the name of the mathematician that first came to your mind. Just really interested in some of your thoughts there. Okay, so far we have Pythagoras, and you may be still thinking about that first mathematician, and that's okay. So I'll give you a moment to consider that, the first mathematician that came to your mind.
Some
And
comments in chat also, Dr. Jackson.
thank you. Oh, we have Einstein, Katherine Johnson. Yes, yes. Descartes. Wonderful, wonderful, wonderful. So go ahead and keep those coming, please. And we'll go ahead and continue. Now that you have put in chat the first mathematician that came to your mind, I would now like you to think about your child, your nieces, as well as your nephews and friends, and all the learners that are in the mathematics classroom. And think about how you would define some of their social identities. And to give you an idea of what I mean by social identities, I would like to share with you that includes their race and or ethnicity, their gender, their social class or socioeconomic status, their sexual orientation, their disabilities, religion, and religious beliefs. So those are some of the demarcations of social identities. Now, once you consider and think about those social identities of the learners that you are involved in, I would like you to take a moment and consider a mathematician that you have learned about either during your K-12 career and your life as an adult that reflects the social identities of the learners that you are involved with. And if you had some duplicates from the previous list, that's okay. I want you to see if you can identify at least 3 mathematicians and post those in chat, please. Are they any different from the ones that previously have come to your mind? So if not, I would like you to take a moment and reflect on what this data is really telling us. What is it showing? Mhm. You have Archimedes. So keep that in mind as we go into thinking about mathematical brilliance and what that is and what that entails. So while all of these individuals that you had mentioned in chat, as well as in the Mentimeter slide, why all of these individuals are brilliant mathematicians who have made impactful contributions to mathematics, really, what message are we sending to our learners and our society for that matter about the mathematicians and what mathematical contributions that we value? We want to strive to ensure our children are confident in themselves as knowers, thinkers, doers, and sense makers of mathematics. In essence, we really want to cultivate their mathematical brilliance. And we say that a lot, and we want to really focus on their mathematical brilliance, but really, exactly what is mathematical brilliance? And specifically, how would you define mathematical brilliance? I'll give you a moment to reflect on that. And I see other individuals posting in chat about different mathematicians that have come to their mind, such as Archimedes, Pascal, etc. But then I'll also like you to post in chat on how you define mathematical brilliance. So we have logical thinkers, okay? So if we're saying someone is mathematically brilliant, that's what we're considering. Any other things that come to your mind? Strong problem-solving skills, okay. Thinking flexibly about math. Now, I always like to resort to the Merriam-Webster dictionary and see how they are defining brilliance. And I see others are also posting in chat, innovative and thinking outside the box. And Merriam-Webster defines brilliance as the quality or state of being brilliant. Now, if brilliance is defined as the quality or state of being brilliant, and we have in our minds defined what mathematical brilliance actually entails, then my question that I would like us to reflect on is, how are we positioning our child, our learner, our friend, our neighbor, and even ourselves for that matter, as mathematically brilliant thinkers, doers, sense makers of mathematics? So how are we positioning ourselves if that's how we are defining mathematical brilliance? I'll give you a moment to reflect on that as well. Because how we define mathematical brilliance is really how we're positioning someone that we're calling mathematically brilliant. And so as you're continuing to reflect on that question, I will also like you to consider, what are we doing as parents, guardians, as well as caretakers to build bridges between our child's culture and experiences with the teaching and learning of mathematics? And you may say, well, I'm not a teacher. But as you know, as parents, we are all teachers. So how are we bridging that information between our child's culture and experiences with that of mathematics. So in essence, representation matters in everything that we do as children and as adults. When our children and ourselves, for that matter, see others who look like ourselves excelling or who have excelled, it empowers them and gives them confidence that they can achieve similar goals and tasks. And also, when our children encounter mathematicians with whom they can identify, they readily become more open to embracing a mathematical identity where their mathematical brilliance can be nurtured. So in the remainder of today's webinar, I would like to take some time to highlight various mathematicians, their mathematical contributions, and ways their mathematical contributions can deepen our children's understanding of mathematics that will essentially foster their mathematical brilliance. So in order to do that, I would also like to not only foster their mathematical brilliance, but I would like you to participate and see how your mathematical brilliance is also fostered as well. So the stories that or the mathematicians that I'm going to share with you is coming from a book series called The Powerful Mathematicians Who Changed the World. And this book series focuses on underrepresented mathematicians, and those are mathematicians of color as well as women mathematicians that we typically don't talk about within our everyday classroom. And so we're going to focus on those mathematicians as well as their mathematics contribution. The mathematician and their mathematics contribution that are exemplified in the books are true. However, the storyline that is used in the book series is fictional. And so the Powerful Mathematicians book series is targeted for readers from ages 2 to 102. So it really dives deeply into that mathematical brilliance. And then as readers are reading the stories, they are engaging in the mathematics of those different mathematicians. I would like to start off with one of the mathematicians that is featured in the book, and her name is Dr. Talithia Williams. Dr. Talithia Williams is a mathematician, as well as a statistician and a researcher who uses data to solve important mathematics problems. She is currently a professor at Harvey Mudd College in California and reminds us that we are all mathematicians who use data to understand our world. And her signature phrase is, "Show me the data." So I'd like to take a moment to read an excerpt from the book just to give you a stepping stone into what that is like. So when Talithia explores questions where the answers aren't clear, she takes a breath and tells herself, we need more data up in here. When we need to make a choice, when we can use data as our guide, data are information that can help us to decide. Talithia examines the data when people disagree. This helps her solve problems mathematically. Like Talithia, you can answer questions that swirl around in your brain. You too can search for data as you find ways to explain. So what I would like you to do, I would like you to take a look at these images and then focus on what patterns that you see. So we had Talithia practices her clarinet with the windows open wide. As she plays, she hears birds sing clearly right outside. She stops to listen to the pattern they are making with their song. She hears 2 notes low and 1 note high and wants to play along. And then we have, here's a specific question. This one's just for you. It's time to collect some data and show what you can do. What are the rules for the patterns that you notice on these 2 pages? So I'd like you to take a moment to examine these 2 pages and then identify any patterns that you notice occurring. You can post some of your responses in chat, please. So on this page, you may notice that there's 2 red birds, 2 bluebirds, and then 2 redbirds. So yes, so one person had mentioned there are birds sitting in a red, blue, red pattern. And we have the birds are grouped in groups of 2 and the different groupings of the different objects. Yes. So there are a lot of patterns that our children can recognize as they're going through this book and learning more about Talithia Williams. And in essence, Talithia really does play a clarinet, and she really enjoys playing the clarinet as well. And you can see the different notes that's located on the music sheets, and notice the patterns there. And then someone else mentioned that the chairs are black and white and they alternate. So then you can answer the question on what color chair should come next in the seating of the stage. So there are lots of different patterns that our children can notice as they're being engaged in the mathematics of the story. You may also notice on the drums of the patterns of the blue, white on the colors of the drums as well. And we have the 4 violins that are in a group that are also, we can continuously notice those patterns as we're going along and learning more about Dr. Talithia Williams herself as a human as well as a mathematician, and then incorporating our children in the learning of the mathematics as well. So here we have a specific question, and this one again is just for you. It's time to collect some data and show what you can do. And this family needs a loaf of bread, some apples, and fresh fish to grill. How much money will they spend? And how do they figure out their bill? So you'll notice that you have the calculations on the screen. They can figure out the different amounts that it would cost. And then on the other side of the screen, we have Talithia actually worked as a cashier while she was growing up. And she had to do some calculations of the customer's change in her head. And so we always want to ask our mathematician, and our mathematician are our learners, so that we can continue to foster their brilliance within that. How many different combinations of coins can help you make 10 cents as well as 25 cents? So what are your thoughts? What are some combinations of coins that will give you 10 cents? So we had 10 pennies, yes. One dime, 2 nickels, 10 pennies. So they're all, as you can tell, they're all different types of combinations that can be infused with that. And having our children to engage in that will continue to foster their own brilliance as they are engaging in the mathematics as well as in the storyline as well. So then we also see that Dr. Williams created models to predict weather patterns. She encouraged in her work, she looked at the winds that were fierce, the thunder was loud. Talithia watched rain pour out of a dark cloud. She anxiously watched the water rising fast. Would there be a flood like there had been in the past? And then we can ask our mathematicians, what do you notice about the sky when it rains or snows, and has some of those questions involved there. And really getting them to really think and critically analyze that. And then going on, we have cataracts make it hard for someone's eyes to see clearly. Talithia noticed this problem affects some people more severely. She collected information to find where this disease gets diagnosed. Then she used the data to send doctors to those who needed them the most. So here we're looking at, here's a specific question. This one's just for you. It's also time to collect some data and show what you can do. And we have ophthalmologists, our doctors who take good care of our eyes, take a look at the vision chart and count the butterflies. So how many butterflies do you see? So we have 4, so we can go through the process and go through that, what we call that one-to-one correspondence by touching and pointing to each butterfly to really engage our child within the mathematics. So in that story is filled with different ways to have your child do the mathematics. And then the story wraps up with, you did it. You solved the problem in this book. You searched for data in each cranny and every nook. Just like Talithia, you have great math skills. Every day you think and wonder, you don't just follow drills. So when there's a solution you need to find, or if you're having trouble making up your mind, before you decide or make a claim, remember that show me the data is Talitha's rule of the game. So this is one mathematician, again, that we typically don't discuss in the mathematics classroom, but we should, because we want to really expose each of our children into all different types of mathematicians and to let them see themselves represented so they can also see themselves as mathematicians. So I would like us to go and look at another mathematician, and her name is Agnes Meyer Driscoll. And she attended the Ohio State University and majored in mathematics, physics, foreign language, as well as music. She became a chief yeoman, which is the highest possible rank she could have, and worked under the director of naval communication in the code and signals section, which is one of the first departments to establish an organized field of cryptology. Agnes decoded the Red Book, which is a set of Japanese codes the United States acquired. Her decoding work allowed the United States to learn about Japanese naval maneuvers, fuel supplies, as well as Japanese naval aviation. Agnes Meyer Driscoll also broke the Japanese military's new code system, which is the Blue Book, where the United States learned the speed of the Japanese battleships. One of her greatest accomplishments was solving the cipher component of the JN25 code, which contained about 35,000 5-digit numbers that represented a word, a number, or name of a place. So in this story of the Mystery Underground, 5 friends go on adventures to learn about a secret coded messages that they find in a tunnel in the woods. And then as they learn more about cryptography and Agnes Meyer Driscoll, they crack the codes and discover something that's disturbing that is happening within their town. So I would like to take a moment to just read you an excerpt of a passage in the book. We have the letter E is used most often in English, followed by T and then A. Okay, so if we make every B in the message an E, can we figure it out? Jake asked. Let's try it, Sela replied. Jake copied the coded message, and under every B, he wrote an E. That doesn't give us too much to work with, Rory said. There was silence for several minutes as they studied what Jake wrote. All of a sudden, Rory blurted out, "What are two-letter words where the second letter is an E?" "I can think of be, he, and we." "Well, don't forget about me," Jake said. Rory laughed and said, "We would never forget about you, Jake." Jake glanced at Rory and said sarcastically, "Ha ha." What if we tried to figure out the why in the coded message by trying to make be, he, me, and we? We could start by replacing the y and with the letter B to make the word be. And maybe we would see something then. Then we could shift the rest of the alphabet and see if we can make any sense of the message after we replace the letters in the message with the letters in the ciphertext. So Agnes Meyer Driscoll was a cryptologist and she really ciphered the different texts. So we're going to have some opportunities to do that as well. And so the text goes on and says, Jake said, "If B is really E, then that is a shift of 3 units to the right from B to E. And if we also shift 3 units to the right from Y, that would be ZAB. So Y would be B." "Here, look," Jake said, writing out the shift of the letters. So we have the ciphertext as well as the plain text. "Jake, can you hand me what you just wrote?" Rory asked. Jake handed Rory the paper with the table of the shifted letters. Rory then filled in the blanks and came up with the message, and the message is below. So I would like you to take just a minute or two to see if you can decipher that message using this Caesar cipher, please. Give about another 30 seconds to see what you believe this message states. If you believe you know, go ahead and post in chat, please. So we have kids in tunnel need to be careful. Yes, yes, yes. So what you have just engaged in is what we call the Caesar cipher. So in a Caesar cipher, we have each letter in the plain text is replaced by a letter, some fixed number of positions down the alphabet. And it is one of the simplest and most widely known encryption techniques that is used today. And it's named after Julius Caesar, who used it in his private correspondence. So yes, so now we get an opportunity to have our children create their own Caesar cipher. We can either give them the prompts and say, okay, this is how the code book is going to be generated, where I would like you to use a shift of 3 to the left, or you can even make it a little bit less structured and challenge the students and give them an encrypted message without the code book and see how they would encrypt it. So you can leave different encrypted messages along the house, throughout the house, and have your child begin to decipher it to try to figure out what it says. And kids, as you know, they get really excited about that and trying to figure that out. And that is using what we call the Caesar cipher. The veneer cipher is another type of cipher that Agnes Meyer Driscoll engaged in, and that's also engaged in this story. And in the veneer cipher, we have each letter in the plain text is encoded with a different Caesar cipher, whose increment or shift is determined by the corresponding letter of another text, which is called the key. And to encrypt a message or a table of alphabet is used, called the veneer table, and it has an alphabet that is written out 26 different times in the rows, as well as having the alphabet shifted 1 unit to the left. And this also shows all the possible Caesar ciphers that exist. And during the encryption, the cipher uses a different alphabet for one row, depending upon the keyword. So really, what does that look like? So this is your table. Now you may have a little bit of difficulty seeing all of those letters in the table. So if you have your phone with you handy, go ahead and access the QR code that will give you access to that particular veneer table. And in the veneer table, the column to your left, that is the vertical column, that is the keyword column. And then you have the alphabet that is always shifted 1 to the left. So each time you go down a row, the alphabet is shifted 1 letter to the left. And then at the top, that top horizontal row is called the plain text letter. So you have the keyword as well as the plain text. So if you are given this particular example, your plain text message is, math is fun. Don't you see how fun math is? And then you have to select a keyword, and your keyword can be whatever you want it to be. In this case, I selected the keyword smile, and you just repeat the keyword smile all consistently until the plain text message is completely filled. So when you're trying to decipher that, you have your plain text along your horizontal, as we had mentioned, and your keyword along your vertical, as mentioned there. And you have you want to figure out what is the ciphertext for this. So to identify that, you'll find the letter M in the plain text, and then you'll find the letter S in the keyword text, and where those two intersect, that is the first ciphertext. And so that will be the letter E. For another example, you do the same thing for the letter A. So you'll find the letter A in the plain text, then find the keyword M in the keyword, and then where they intersect is that letter. So I'm going to give you just a couple minutes to see if you can figure out what is that ciphertext there by doing that same process. So find the letter T in the plain text, and then go down to the letter I in the keyword, and where they're intersecting, that is the ciphertext. If you come up with that third letter in the ciphertext, could you go ahead and post that in chat, please? We have B. And you can go ahead and continue, but you can check yourself. I'm going to go ahead and show you what that ciphertext looks like, and you can check yourself with that. So we have several of you putting the B in chat, and this is the ciphertext of that. So with that ciphertext, you can still, it's a little bit more involved than the Caesar cipher, but really looking at the veneer and have it a step up with that. And you can also decipher the words that are going in the row of the table by the corresponding keyword and finding the position of the ciphertext. So you can work that in reverse. So if my keyword again in this case is smile, then I could find the S in smile and then go over to the letter E. And then I know my M has to go up to the M for this ciphertext. So I can work that process in reverse by doing that. So I have math is fun. And I would like to give you one more challenge. So if this is my ciphertext, I would like you to figure out what my plain text is if my keyword is Chicago. As you all are exemplifying your brilliance. If you have, I know we're getting shorter on time, but if you have the first two letters of this plain text, please go ahead and post in chat. Yes. So we have GL. So if you continue that process, what my message is to you is glad you are here. So thank you so much for being here. And then I would like to take the last 5 or 10 minutes that we have together and go through some of the mathematicians that we have in the A to Z book that will continue to focus on the mathematical brilliance of each one of our learners in the classroom as well. The first mathematician I would like to share with you is Alejandro Adin. And he was born on November the 24th, 1961 in Mexico City. And when he first came to the United States, he didn't speak any English and he experienced culture shock. Luckily, he had very supportive teachers who helped him learn the language and valued who he was. One teacher he recalled helped him love the conceptual aspects of math. He stated, "What is amazing about mathematics is that if you understand the underlying ideas and methods, you don't have to memorize facts and formulas." His dad always told him, "You are the architect of your own destiny." And Adam followed this mantra and has done amazing work during his career, earning numerous awards and accepting prestigious positions, including the director of the Pacific Institute for the Mathematical Science, CEO and scientific director of MITEX Canada, and the president of the Natural Science and Engineering Research Council of Canada. He is also a fellow of the Royal Society of Canada and a fellow of the Canadian Mathematical Society and a member of the International Mathematical Union's Committee for Women in Mathematics, as well as a corresponding member of the Mexican Academy of Sciences. So Adim's work really focused on algebraic topology and group cohomology. And cohomology of groups is what Adim found this very fascinating because it connects areas of algebra with topology. And it was his primary mathematical focus to look at the algebraic topology. And we know that algebraic topology is an area of mathematics that developed from another advanced branch of mathematics called topology, which is the study of topological spaces. And topological spaces are essentially all around us. In fact, the three-dimensional space in which we live is an example of a topological space. So in the case of algebraic topology, mathematicians become very interested in classifying objects according to which objects can be continuously deformed into other objects. A continuous deformation is an example of a continuous function. For example, as you can see, this particular coffee cup that's identified here can be continuously deformed and transformed into the shape of a donut. And with that, we can also take this cube and continue to mold it continuously to have it the shape of a sphere. However, we can't take a sphere and transform it continuously to a donut. And so we want to think about the ways that we can continuously shape those objects. And as we're moving forward, I would like you to think in your mind, how can you manipulate that cube so that it forms that sphere? And all of this work here led to what mathematicians consider the importance of numbers of holes within the object. And this number is called the genus of the object or surface, and its topological invariance, meaning that it does not change when the object or surface is continuously deformed into other objects or surfaces. Cubes and spheres have no holes, so their genus is 0. A one-handled coffee cup and donut each have one hole, so their genus is 1. And then we have many different types of dog toys in our house and different types of pastries that we eat that have 2 holes in them. And that actually has a genus of 2. So the number of holes represents the types of genus within involved. So with that, and with Alejandro's types of mathematics, we can get our students and our child, and they engaged in algebraic topology by doing some of these simple types of mathematical activities that we can have around our home. So we can take a plate and a bowl or a coffee mug and a donut shape and talk about with our child about how we can take that and have it deformed within that. We can even give our child some Play-Doh and have them continuously transform those shapes into those different particular types of newly formed shapes, such as going from a square to a rectangle, etc. So there are many different ways to engage in algebraic topology that we think is so foreign and too high level, but our learners and our children are brilliant mathematical thinkers and doers, and they can engage in this, what we consider high level mathematics as well. And as I had mentioned, we can take some clay or Play-Doh and have them create some topically equivalent shapes, and they can just talk to them about that and showing them the plates could be formed into a sphere, et cetera, and talk about those different things and have them engage in those mathematics and make sense of that. And then with even some of our students who are in high school, we can even engage them in some mathematics that goes into some calculus where they're looking at the volume of a torus and seeing those algebraic topology and using that particular, finding that volume of the torus based on that. And there I provided the answer for you as you're beginning to manipulate that with the torus. I'm going to take about 4 more minutes because I do want to share with you one other mathematician, and her name is Kathleen Earnshaw. And she was born on October 1st in England. And when she was born, she had a genetic condition that affected her hearing. And with that affection, she was almost completely deaf, but she didn't let that, she used that to her advantage and her mathematics ploy. And she also became a member of the National Council of Women, and she raised the awareness of the state of schools in Manchester, and highlighted the appalling conditions of the existing school structures. And then even at the seasoned age of 85, she published a book about the most perfect pentagonal magical squares. And her work is most recently denoted with the magic cube, also known as the Rubik's Cube. And we can say that she is the very first mathematician that can, that can claim that her accomplishments in mathematics, she actually received an injury from that, so to speak. So through her sheer determination and her tenacious approach in solving the Rubik's Cube, it resulted in her first known cubic thumb, which is an injury that resulted from the turning and the twisting movements of her joints that severely damaged her tendons. And once again, she is the one mathematician that can claim that mathematics actually injured her. which I think is totally fascinating. And many of us are very familiar with the Rubik's Cubes. And from that, we can do a lot of different types of mathematics with that by just talking about the different directions involved within the Rubik's Cube, such as turning, what does it mean to turn clockwise as well as counterclockwise? How many faces are on each side of the cube? And just going into some of those mathematics along those lines. So as we are continuing to foster the brilliance of each and every one of our learners as doers, thinkers, and sense makers of mathematics, I would like to leave you with these 3 questions to have us to consider continuously. Which mathematicians do we include in our mathematics lessons? And how do we value their mathematical contributions in our mathematics instruction? So once again, this doesn't have to be involved in a classroom aspect. And how are we positioning our children to be competent doers, thinkers, and sense makers of mathematics? And then also, how are we acknowledging their mathematical brilliance in everything that they do? So thank you so much.
Thank you so much, Christa, for a really
Thank
wonderful
you.
program tonight. And thank you, everybody, for being with us. And let's keep spreading the mathematical brilliance, everybody. Take
Thank you
care.
so
Hope
much.
to see you again soon. Good night, everybody.